Good. So, hi everybody. I'm Karen Lightman. I'm the Executive Director of Metro21 Smart Cities Institute. I'm so thrilled to have Ken Steif with us from University of Pennsylvania. So Metro21, we are interdisciplinary. The 21 in our name talks about taking 21st century technology and applying it to solve real world problems facing our region here in southwestern Pennsylvania. A big part of our success is the partnerships that we have with municipalities, nonprofits, and we co-create. We design and deploy and evaluate with our partners. And we've got about almost 20 projects that we're actively involved in. The list keeps growing. I'm really thrilled that we get to work in lots of different areas, from machine learning to design thinking and user-centered design, all over the southwestern Pennsylvania. One sec. Okay, there we go. Okay, so there's Ken. He's our speaker today. And Ken's title is he's the Master of Urban Spatial Analytics program at University of Pennsylvania and runs a consultancy as well. He's got a side hustle called Urban Spatial that's at the intersection of data science and public policy. Ken has definitely been at the forefront of data-driven public policy for more than 15 years, probably closer to 20. He's got fantastic experience in geographic information systems, GIS, applied statistics, interest in housing policy, child welfare, education, economics of neighborhood change, transportation policy, and more. I'm really excited when I heard that Ken just came out with a new book called Public Policy Analytics Code and Context for Data Science and Government. I said, come attend and I'll host you at our Lunch and Learn. We're so thrilled to have you. And with that, I'm going to stop my share. I'm going to hand it over to Ken, and he is going to take it away. Ken, the floor is yours. Welcome.
Thank you so much, Karen, for that really wonderful introduction. I really appreciate it, and I'm so grateful to be invited to speak to you all today, a group that I have also great respect for. Yeah. Terrific. All right. As it was mentioned by Karen, I kind of wear two hats. I run a graduate program at the University of Pennsylvania called the Masters of Urban Spatial Analytics, where we try to train the next generation of civic technologists working in government to use data to help governments make better decisions. And you will see that idea is at the core of this book. It's also at the core of this consultancy I run with a similar name, Urban Spatial. We build mostly open source data science projects for governments and nonprofits. I will tell you, if you're interested in entrepreneurship, you should by all means start a business. Giving away your code for free is a horrible business model. I just want to let you know. But if you want to have social impact, by the end of the presentation, hopefully you will see why I think that that kind of transparency is so important. So here is, first of all, you can see, here's the book, and I'll show you how you can access the open source version of it in one moment. But I'm quite proud of it. Someone with like the kind of ADD that most people like me have, who are interested in data and solving problems. I am proud of having the discipline of finishing it. So again, I'm grateful to be here to talk to you all about it. The agenda is pretty simple. Really, the talk is broken out into two parts. The subtitle of the book is Code and Context for Data Science and Government. And you can see that part one, I'm actually going to switch it up. We'll talk about context and why context is important. It will really talk about why I think that data science and data-driven decision-making is very similar to planning. And so that's my background. I have a PhD in city planning. The program that I run at Penn is embedded inside of the city planning program. So the first part will be about context, and the second part will be about code. The book is chock full of code written in the R language. It's totally reproducible, so you can hack together parts of the book to solve your own data science problems. All right, so for those of you with a phone, I will drop a link after, when we have a Q&A to the book, but you can, the book is set to come out. It's for pre-order right now. It's set to come out in July in print, but the book exists as a book down book, and you can use that QR code to access it. As it says there, it looks beautiful on mobile. But if you wanted to copy and paste the code, for instance, it's very difficult or a real pain to have to write the code from the book. The code is all there online for you. The whole book, in fact, is there online for you. And I put there, as I wrote a book, as I mentioned, I'm just, when you write a dissertation to get a PhD, you're like, how could I possibly do that? That sounds insane. And then you get that done, you're like, I might actually have the discipline to write a book. And I just want to mention this, I didn't just like do this. This book I pieced it together over probably 3 years, and it's the text that I use in my fall class, also called Public Policy Analytics. And the real challenge of, I think, writing the book is you'll see every chapter is a different use case, and trying to come up with the kind of narrative themes to weave those chapters together, right? It's not a novel where from one chapter to another, the characters stay the same. It's quite different. The characters change from chapter to chapter. So this first section is really about the narratives that I think hold it together. And as much as I love data and using data to solve problems and using data to help government, I'm a policy wonk and believe deeply in having an impact. And so I wouldn't say this book is highly not theoretical. There's a bunch of code, but particularly in the introduction and in the conclusion, and then hopefully weaved throughout, are some important themes that have to do with policy context. And I'm going to start with that. Specifically, the quote from the first sentence of the book. Although many readers will choose this book for an introduction to R, geospatial data science, and machine learning, my goal was to write a book about public sector decision-making. I am super interested in how it is the decisions are made at government and how services are delivered, where the rubber meets the road, as they say. Now, of course, people will come and people will learn our data science and machine learning, but these are these narrative themes that are really about decision-making. And ultimately, I try not to convince readers that we should build all the algorithms, but really how to develop them with community, with fairness, and with utility in mind. So here is a real key theme of the book, and that is that programs, government programs, that's service delivery, programs and algorithms are really comparable to one another. Both make decisions about how, sorry, that's a terrible misspelling of the word R. Both make decisions about how services are delivered. And both, a program, it may or may not be, likely is not guided by an algorithm. There's a person making a decision, but a person's decision can be a black box, as an algorithm can. Both decisions can discriminate. And if you go back into the history of government resource allocation, there's just nothing but a history of discrimination long before computers and data. But ultimately, both, I think, can better the lives of citizens. Now, you've heard over the last 5 years, just headline after headline of horribly designed government algorithms. And I would argue, when Facebook decides to design a housing algorithm with an engineer who has no experience in the law, that's really a recipe for a disaster. And I would ask you, have you seen a study where an algorithm is making a really great decision? And I think they're out there, and I think we can create them. I just don't think the technology is robust enough for enough of those examples. So again, I'm not trying to push algorithms. Again, it's just a way of developing some government algorithms with some tips to make sure that they are not discriminatory, that they are not black boxes, and that they ultimately can help more than hurt. Now, I ask you, have you ever considered how governments make decisions? And I've been building not only algorithms, but just data tools in government for about 20 years. And these are, when I go in to have a meeting with a government agency about a program, I don't say I'm here as a data scientist. I say I'm here as a planner, and I want to know how you make this decision already. And I tend to see these 4 answers, some more rare than others. But the first answer, when I ask them, how do they make a decision? It's very rare, but they might say that, they really don't know how this decision is being made, or it's being made sort of off the cuff. That certainly is rare, but it certainly happens. The second one is very common, a political decision. They said, we make this decision because the political official who sets my budget expects the decision to be made like this. A third way, very common, is institutional knowledge. Why have you made a decision like this? Or how do you make a decision? We've always done it this way. That's institutional knowledge. And finally, I think the one that I hope this book, helps to move along, and what I hope is growing, is an evidence-based decision. That we make this decision because the data and evidence suggest it's the best decision. And so before I even jump into the fancy technical stuff, it's important to understand at a more human level how a service is delivered. All right, so I want to tell you a story about government decision-making and algorithms. It's a story that some of you might know. It's just one of my favorite stories. And the story takes place in New York City. And in 2017, Mayor de Blasio created the first of its kind automated decision systems task force, basically bringing together an interdisciplinary team of experts across the spectrum to understand how algorithms and data were being used to make decisions in New York City. And the task force worked for a few years and ultimately were stonewalled by agencies. They'd go to an agency and say, we know you're using this algorithm. Can you tell us something about it? And the agency would basically say, go away. And they saw this across the board. And I think it's not just my opinion. I think the widely held opinion is that what ultimately was a revolutionary idea in creating some transparency around algorithms was a massive failure. And due to this, I like to ask this question: why was this effort to develop more effective governance around algorithms such a resounding failure? Now, there are many reasons for this, but I want to focus on two. And the first one, I just try to tell you that algorithms and programs are comparable. If government has an incentive to create a good program, but it's failing, they're not going to tell you about it. Whether that program fails because of bad human decisions or bad algorithmic decisions, why would they divulge any information about it? So doing so is a political liability, and it's just easier for them not to mention anything. The second reason I think that this effort failed is that New York City, like many governments that are using algorithms, do not have a set of community standards. And I'll explain this, but there are many stakeholders involved, and some of them don't understand these algorithms or their use. And without these community standards, which will be a big theme of what I'm going to talk to you about today, it's largely going to be difficult to stand up effective algorithms. So I want to give you an example from criminal justice, because this is where algorithms are probably the most ubiquitous particularly in cities. In the book, I devote 2 chapters to building justice-related algorithms. And in there, I discuss a legal theory called disparate impact, the idea that algorithms may discriminate even if the people who develop those algorithms don't intend to discriminate. Police algorithms or criminal justice algorithms probably are such early adopters because there are significant social costs associated with crime. Social cost is a big theme of the book as well that I will talk about. And for those of you who don't know, many criminal justice algorithms are created by collecting just a wealth of data from the sources that you see here. And they might integrate all of that data either to develop some dossier on a person of interest, to build an algorithm to estimate the probability that someone is part of a gang or someone might commit a crime. And ultimately to try to make this intelligence actionable so that we can allocate some resource. Now, critically, there are multiple stakeholders who each want to have a say in the use of these tools. They each have their own goals. They each have their own expectations of such a tool. They certainly have differences in their technical understanding. Obviously, police want greater tools for crime fighting, right? Full stop. Communities are weary of these tools because they see them as increased surveillance, understandably so. And politicians are really caught in the middle. They have no idea what this technology is. They have no idea who it helps or who it hurts. and they frankly don't understand, should they be supporting police or those communities? And I think it's going to take a lot more for these politicians to come up to speed on what this technology actually means. Now, that discord between these stakeholders, I think, plays out along a spectrum. That if these groups could develop some community standards about the use of these tools, if they could agree, it might actually lead to some useful new crime fighting tools. But this disagreement will ultimately stifle innovation. And I think that's where we are today. But of course, that doesn't stop police departments from procuring these tools, particularly from third-party private companies that will gladly sell you a predictive policing algorithm. And again, I think that what prevents this discord is these community standards. That in a way, I hope this book is not for advocates really, but I hope this book does help to further a conversation about creating these community standards. And I just want to mention that law enforcement is always the discussion because it's always just in the headlines, but there are other domains besides law enforcement that have really significant social costs where algorithms could play, and frankly are playing a significantly positive role. And some examples would be child welfare or eviction or drug treatment. These are other domains in government where there are significant social costs. So in the conclusion of the book, skipping directly to the conclusion, because it is important part of the context piece, I ask, how do we foster these community standards? And this chapter lays out what I just did about the New York City example. And I want to very quickly run you through this idea that I propose called algorithmic governance for creating community standards in the use of these tools. And again, it's rooted in this idea that algorithms and programs are effectively one and the same, and that we should adopt frameworks to design algorithms in the same way that we design programs. So I'm a city planner. There are some tried and true methods for developing government programs, and I want to borrow those ideas for developing algorithms. And there are 4 key steps. The first one is based on the problem that, as I mentioned, the existing program may just be poor, which is why an agency doesn't want to talk about it. So the first step is simply to evaluate the existing program, which is something that we do anyway. It's actually fertile ground in this process for some academics to get involved. Evaluate the existing program. The second step is that the stakeholders I mentioned, they have no idea. They don't understand they may not even know the program exists. They may not understand how it exists currently. They certainly likely do not understand how an algorithm can play a role. And I think that community engagement, which is a big part of designing programs in government, is really at the heart of this idea of algorithmic governance. Go out there, be transparent, talk about the effectiveness of the existing program, the data that we collect about the program, the prospects for using that data to help make better decisions. And I mean that, really engage the community. It's an important part of city planning, which is why it's in this framework. The third step is about this idea that government data may be biased against a protective class. Government resources are not randomly distributed, and they may be distributed in a certain way that means that if we use that data to build an algorithm, that algorithm may lead to what we call disparate impact. It may be discriminatory. And so the first thing to do is to not procure an algorithm from a third party. Don't do that. Those algorithms are black boxes. They are unhelpful. Instead, this is where open source comes in. You know, building algorithms, posting the code, opening up the black box, demonstrating these algorithms are fair and equitable. And again, it's at the heart of the books. The book is free and open source. And I believe in the idea of what I call open analytics, that all of these governments share the exact same use cases and decision-making problems. If a government can design an algorithm and post that code on GitHub, another government can come along and copy and paste it and stand it up in their own community. So be as open and transparent about building algorithms as possible. And finally, step 4, you know, a really useful step, is this new algorithm, does it do a better job making decisions than whatever the business as usual approach was. And we can do this with a randomized control trial. Again, more opportunities for academics to get involved. And we can sort of close the loop and see if we've done a better job ultimately in making a service delivery decision. So that is a quick run through the context aspects of the book. As I mentioned, that's heavily in the intro and the conclusion. And then I weave these themes throughout the book, because in the book, you are writing code and building these algorithms and opening up the black box. And I try to get you to think about these ideas of social costs, of community standards. And, you know, interestingly, I try to get you to think about them in the context of statistics, of model building. And my hope is that what makes the book strong is that you get it from a social science perspective. There is a lot of social science context in many of these chapters. And then you get it from a code and from a statistics perspective. And I will now spend, I think, hopefully the next 12-ish minutes thinking about the code side. And my hope is you will see the synergy between the context and the code. Just one is more social sciencey and one is more data-driven. All right, so the book is written entirely in R. It is, as I said, fully reproducible. It's written in this beautiful book-down format. You can buy the book, but you can also access the book online. This is what it looks like if you were looking at the web page, and you can very easily copy the code. This is from a chapter on the last chapter of the book, building algorithms that Uber and Lyft use to figure out, where to put its drivers to lower response times, which is, by the way, a use case that an ambulance driver would love and that we've built in the past, in fact. So you can see what it looks like. All of the code, the English language, as well as the data visualizations are all there for you to read and check out. Now, the first there is really one key theme around the code, and I introduced machine learning, or predictive modeling, forecasting, what have you, with this plot. It's one of my favorites. It's recreated from one of the very first city comprehensive plans ever created. It's the 1925 plan for Cincinnati. And what the authors of this plan are doing, and what the authors of any comprehensive plan is doing, is in order to plan for a city's future, you have to understand the future demand. And in this case, we're looking at population by decade. Interestingly, the authors write, population forecasting is the, quote, obvious basis upon which scientific city planning must be formulated. Population forecast, the basis of scientific city planning. And frankly, here you can see what this graph shows is the orange line is the forecast that the planners made. The green line is what I superimposed, what actually happened in Cincinnati with their population. These city planning students to this day are still taught to extrapolate a line to make a population forecast. This is a terrible forecast, no doubt, obviously, right? These authors in 1925 are missing out on massive interruptions or shocks, like a Great Depression, a World War, deindustrialization. They really assumed that they understood the interrelationship of really complex systems like housing markets and labor markets, immigration, politics, technology. And in fact, forget 1925, we have no understanding of these systems or their interrelationships, but they felt that they could confidently forecast into the future, so much so that they insisted it's just the basis of scientific city planning. Now, I got news for you. As I said, we're just so far from understanding those interrelationships. And in the book, the goal is really to make predictions in more bounded systems, smaller systems, where the recent experiences that we observe more reasonably generalize, that's the term I use, into the near future. I am not interested in forecasting for 50-year horizons. That's silly. I am interested in recent experiences and testing whether those recent experiences can generalize into the near future. If I can observe the experiences of homelessness over the last couple years, can I use those experiences to predict for homeless individuals over the next 2 years, or those involved in drug treatment, and the list goes on. And this quote right here, I won't read it to you, but it is how I try to conceptualize this for my social science students. The idea of machine learning is to borrow the experience of people or places in the recent past and open up the black box and understand if those experiences can generalize into the near future. And this word generalizability is going to come up a lot in this section. And what I'm going to try to do is to give you 3 examples from 3 chapters where we open up the black box. So chapters 3 and 4 of the book are where I introduce machine learning, and specifically geospatial machine learning, which is a niche, I will admit, but it's one I'm very fond of. It's one of my favorite use cases because it's been around for decades, and it's predicting house prices, and specifically house price prediction to be used to appraise property taxes. So in my city, in Philadelphia, like many big cities, we don't send appraisers to everyone's houses. We use recent transactions and we build algorithms to try to predict the value of everyone's house. And that's how we appraise your house. In these 2 chapters, I introduce regression modeling, and it will be simple for those of you who have taken regression. But I do talk about things like geospatial feature engineering, how to measure the exposure from, say, every house to how do you quantify the exposure from houses to crime or houses to amenities, et cetera, et cetera. And ultimately what I show is you have to account for spatial effects, in this case, like a neighborhood effect, in order to really be able to predict houses, that the price of your house obviously is not just, you know, the number of bedrooms and whether you have marble countertops, but there are all of these spatial effects that play a role. And of course, when you rent a house or you buy a house, you're not just buying the building, you're buying a bundle of these neighborhood effects or these amenities. And so I show you in an algorithmic setting how to define these things, how to parameterize, or what we call feature engineering, how we engineer features to account for these neighborhood effects. And I show you some more traditional spatial methods. Once you think that you account for these effects, how can you test the extent to which you've captured all of these neighborhood effects? Here's an example of a statistic called Moran's eye. And I show you how to use these spatial features to improve these models. Now, ultimately, at the end of these chapters, what I want to do is to try to understand errors, the extent to which I can successfully predict home prices. And I want to break it out by race and by income. I want to see, am I marginally more or less successful for, say, minority neighborhoods versus white neighborhoods, or low-income neighborhoods versus high-income neighborhoods. And ultimately what I show, you can see on the bottom left there, is that if this algorithm in the book, if it were put into production, it would disproportionately over-assess, and that means overtax poor minority neighborhoods. And this is, I put up this picture from Twitter. This is something that's happening in my city and in other cities. We are finally realizing that these appraisal methods are actually discriminatory and that certain neighborhoods are being overtaxed. And if you were a county appraiser, you could use these book chapters, again, to open up the black box to your models and see where it is and the extent to which some of these biases have arisen. So not only is this the introduction I provide for machine learning, but I do think it's an important step. I just want to mention, it's an important step in understanding this concept of generalizability. And what that means is that this algorithm doesn't generalize to different urban contexts, and therefore it's not in its current state a useful decision-making tool. Again, it doesn't generalize to poor or minority neighborhoods.
Hey, Ken, there's a question from the chat, and I'd rather do it now than later. And the question is median income considered in the appraisal model?
No, we are not taking, in the book chapter, we do not take census data. This is a great question. Can you take census data and include it as a feature to predict a house level outcome? So the house level outcome is the price of the house. Can we use from a census tract the median household income? And the answer is no. And the reason is because in a regression model, it will borrow that median household income from that larger spatial unit and basically apply that to many smaller houses that exist in that census tract. This is a very technical question. I'm not sure if I'm answering it well, but ultimately what we're looking for are solely house level features or house level predictors. I just want to mention one last thing about that is that I can still account for the fact that in this community, there is a shared income level because home prices tend to cluster. So a big part of chapter 4 is understanding that there are rich neighborhoods and there are poor neighborhoods. And how can I build some of these neighborhood effects that will account for that? So I urge you, whoever asked that question, I'm sorry that I don't have the chat up. Thank you for your question. I urge you to check out chapter 4 because I address this kind of neighborhood effect. But if you're building these kind of models and there's so much data out there, a Kaggle competition or something, if your outcome is at the parcel level, you don't want to use a group predictor. If I'm predicting for a person, I don't want it. If I'm predicting for a student, I don't want to use a classroom median. That's maybe a better example because it will average out that classroom median across all those children. Hopefully that's a useful answer for you.
Thank you.
Right.
I think you nailed it. Thank you.
Thank you. I want to move on to another chapter. How am I doing time? Good. On predictive policing, which is maybe the worst of all machine learning algorithms that governments are currently using. But I demonstrate in the book because it's the first example of an open source predictive policing algorithm. Right now, these are built by third parties, big companies like Palantir, and sold to governments. And I wanted to put out the guts, and because I want civic technologists to be building these algorithms and checking their local governments. And in fact, so predictive policing, if you don't know, it predicts the probability or the risk of crime in for every location in a city, and police departments use that to allocate their police officers in space and in time. And just so you know, by the way, if your city is using this algorithm, my suggestion is you reverse engineer it and build a website, something like robmenow.com, because you would replicate their algorithm to know where the police are hanging out, where they're patrolling, and effectively see where they're not patrolling. But the other reason I show it is because it demonstrates the importance of community standards. So these are purely spatial models where there is risk or opportunity for something in space. And I call this latent risk. And particularly for many outcomes that we're interested in, they're pretty rare. And just because we don't observe a particular algorithm doesn't mean there's not risk for that. I'm sorry, just because we don't observe a particular outcome doesn't mean there's not risk for that outcome occurring elsewhere. And so to estimate that risk, we're going to borrow the experience from the places where we observe a crime, for instance, and test the extent to which that experience generalizes to a place we don't otherwise observe it. Now, the reason these algorithms are so, again, prevalent is because of the social costs. Police departments are struggling for ways to fight crime. The problem is that all criminal justice models suffer from a lack of generalizability. And the problem is that the data collection mechanism, how the data is collected, is extremely flawed. And this is what a social scientist might call selection bias. Now, I don't have to tell you that police officers selectively enforce certain crimes. I know you will be shocked to learn that. What that means is they are not enforcing, say, drug crime equally in every neighborhood of a city. And that means that the data that we collect on where drug crimes occur are highly biased to the selection biases of police. And if you go and read chapter 5, you know, I provide what I think is a fairly robust social science introduction into some of these ideas. But I want to mention there are plenty of use cases where this selection bias doesn't occur, where we build these algorithms. Examples might be like building fires or building demolitions, zoning variances. If you're in real estate, these algorithms are pretty valuable. But so building fires, I can't, you know, if there's smoke coming out of a building, I can't selectively choose not to fight that fire. So I've used these algorithms to predict building fire risk as a way of doing like smoke detector outreach. But again, I think it's for me, it was important to do this in predictive policing because I want people, as I said, I think this is the first example of someone opening up this kind of algorithm and allowing others to build them. In this chapter, I also we talked about the importance of feature engineering in space. I provide some pretty robust feature engineering examples for capturing what I call the spatial process, for really drilling down and being able to effectively predict the hot spots as well as the cold spots. So if you've ever tried to model something that's highly nonlinear, you may be able to predict well in the middle, but you miss those kind of outliers. And so I provide some pretty nuanced methods for, as I said, predicting the hot spots and the cold spots. Now, in the end, as I mentioned, what you get is you collect these features, you build a simple regression model, and you get a predicted surface. So on this map, you can see here is my final predicted surface of risk. Here is the observed burglary is the outcome of interest. If you didn't know, this is in Chicago. And a police department, as I said, might use these maps. In fact, they tend to build them at like a 15-minute interval. Here, we're just looking at a cross-section to allocate crime fighting resources. Now, here's what I want to ask you, and this is the community standards question. I can assure you, as I hopefully already have, that these models are biased, but are they useful? Now imagine if I back tested this algorithm on historical data and showed that it would have prevented 20% more burglary than the current approach to how police are allocated. And what if we could show officials in Chicago that if they spend $100,000 per year on a license to my fancy predictive policing software, that I can reduce property crime by $10 million. Do you think they should buy it? Should we all start a new predictive policing business and sell this technology? Now, if you're a police officer, you're going to be like, yeah, 100 grand, let's do it. You know, $10 million in savings, that's like a cost benefit, no brainer. Where do I sign up? And others, you're going to say, no, this technology is highly, myself included, just massively biased. And there's no way we should be using this technology effectively to increase police presence in neighborhoods that we've systematically discriminated against throughout the entire history of America. And this is the exact example of the lack of community standards I talked about on the context side, that some stakeholders, this is a no-brainer. Other stakeholders are like massively offended at just the concept of doing this. And just want to reiterate, without those community standards in hand, the cost benefit is really too great for police departments. It's really too perfect. And they're going to continue to procure this software. I had a third use case also in criminal justice around algorithmic fairness in recidivism models, which is a classic example. But I want to skip over it because I want to leave enough time for questions and answers. But this is chapter 7, and all I've shown you is place-based models, but there are chapters on people-based models, on making decisions on the allocation of resources for people. And this is an example, again, about how to open up the black box of these criminal justice algorithms to understand bias. And the point I make in the chapter is that, with this example, it's more, the social cost is increased surveillance. But in the example of using algorithms to decide who gets out of prison and who doesn't, it leads to a real social cost to an individual and to a society. And that social cost is probably greater than just increased surveillance. So maybe it's a bit of a teaser, but go check out chapter 7. All right. So there are two main themes that I'd like you to take away from my talk today. First of all, that programs and algorithms are comparable. They both exist to make decisions and to deliver services. Both can be poorly designed. Both can lead to bad algorithms. But there are obviously some terrific government services out there. And I think there is a promise for some terrific government algorithms. I think some exist today. And I think that increasingly more can exist in the future, but not without the ability for government itself, not third-party companies, to open up the black boxes, to develop with transparency and with community involvement. Second, I try in this book to how to open up this black box. I really provide you code to code up these algorithms and then open up the black box. And I hope some of these methods become standard. I don't see them out there. I see a lot of complex engineering papers, but I think that the idea of, does this model discriminate in different, in a minority versus a white neighborhood? I don't think that's an overly complicated engineering idea. I think it's a simple social science idea. And so I hope this book is written for social scientists, and I hope some of these methods become more accessible in that regard. And finally, I mean, this is a given. There just needs to be more attempts by politicians and other stakeholders to understand this technology. And I think there's room for everyone to embrace like a more inclusive and community involved approach to this that's not about statistics, that is very much around designing programs. And if we don't do this, companies will continue to come along and sell their algorithms. And those black boxes will continue to get us all in trouble. They will continue to perpetuate, I think, most importantly, systematic racism. And so more community buy-in is where I will leave you all. And again, I'm just super grateful to be here. And I thank you, Karen, for inviting me. And hopefully you all have some questions.
This is great. I was humming and nodding my head the whole way. And actually, you've touched upon a lot of issues that we have addressed and keep talking about at Carnegie Mellon, including predictive policing. I think I always worry about kind of what I call throwing the baby out with the bathwater. And so I like your idea of opening the black box and having conversation, because the technology exists. And so it's important for us to use it for good if we can, but it's gotta be thoughtful and intentional and iterative. And I think that's really important. So I'm hoping we'll get some more questions from the audience. I see Professor Al Bloomstein is with us. I would love, Al, if you feel comfortable asking a question, would love to get you there, have you join us. Al, can I tease you out of unmuting? Maybe try and get him. So I guess while Al is working to do that, I'm curious, we have a lot of trillions of dollars are going to be coming to state and local governments with the American Rescue Plan. And Al, do you feel comfortable asking a question?
Well,
or making a comment?
One issue is that, can you hear me?
Yes, we can hear you. Thank you.
Okay. One issue, any regression model you have will have factors like socioeconomic status as part of it, for location or individual. And inevitably, there is a race correlation between the socioeconomic status and race. So inevitably, such models are biased in terms of overbringing race, excessively incorporating race effects. One means of reducing that is to incorporate race per se as one of the variables in the model. If you do that, then you lower the influence of its various race correlates associated with other socioeconomic variables like socioeconomic status, whether employed or not, education or not, because they're all correlated with race. So that reduces the influence, the race influence in these other variables. Then when you apply the model, you drop race from it. The other variables have their reduced weight associated with race. And so it reduces the effect, but it still doesn't eliminate it. And the challenge always to any such algorithm is, damn it, it's a rotten model because it overestimates a race effect. And this is one approach to at least reduce, if not eliminate, the race effect. What are your thoughts on that issue?
It's a great point. And I want to give you a technical answer, and I want to give you an algorithmic governance answer. From a technical standpoint, I'm sorry, if someone could mute their mic, I'm getting some feedback. From a technical standpoint, regression models that have race in them or not, it really doesn't matter because the outcomes, race is baked into the outcomes. There is selection bias, right? So like a good econometric model that deals with race tries to randomize across different racial groups so that that selection bias isn't baked into a regression coefficient. And that's if we're interested in inferential statistics. Again, that race is going to be, there's going to be selection bias, race will be baked into the outcome, even if we account for it or not as a independent variable. That will bias our coefficient. Now, predictive modeling actually offers some freedom from that restriction. And I'm formally trained social scientist, so I spent years, you know, in a classroom with like 9 chalkboards, and the econometrician is like furiously writing equations and rolling up chalkboards to the sky and continuing to write equations. So selection bias is my approach for thinking about these things. But what's interesting from a predictive standpoint is that it really doesn't matter. I don't really care about the coefficients of a model. What I care about is, are the predictions of that model, will that lead to a better decision-making framework than what's currently available? And that's the whole idea about opening up the black box. With a regression coefficient, there's not much I can do to see if there's selection bias. All I can do is advocate for a better research design. But with prediction, I can actually open the black box and see the extent to which my prediction is biased. And what's more is I can then go back and look at the current decision-making and see how that is biased. And I can ask if the automated approach, if the algorithm approach will make a less biased answer. So one thing one takeaway, one sort of bumper sticker is that the way of thinking about how race or any discriminatory factor is baked into data is, it's different in predictive modeling than it is in inferential statistics. And frankly, I think it's a lot more freeing because we're talking about like actual applications and not just interpreting a regression coefficient. So I appreciate your question. I hope that was helpful.
Thank you.
I agree that race is baked in how you do it, but recognize that the race effect is distorting race effect will be diminished in the values of the race-related coefficients when you introduce race explicitly in the formation of the model, because race itself is carrying that effect, and thereby diminishing the race bias in the other variables. That was the point. And but you're not going to eliminate it as long as there's any correlation with race, and almost everything out there is race related. That was the point I was trying to make.
Understood. Thank you.
Thanks, Al. So I'm going to go, I encourage folks in the audience, we have a couple minutes left to send a question in the chat or raise your hand. Thank you, Al, for letting me pick on you. Our former dean of college. And I guess I want to talk about like looking forward. You know, there's going to be an infrastructure bill that's going to invest in our community's social fabric. And so my hope is that the first part of your talk was the policy and that some smart decisions can be made. So who needs to read this book right now as they're thinking, like, where do you want to see these tools being used? Is it throughout city government? Do you want to make sure it's in social services? Is it like, where do you feel like we can move the needle the most?
Such a great question. And you kind of got it when you first started stating this question. There's now, you know, 6 or 8 months ago, every government was screaming about how much they're going to have to cut services. And now they are awash with cash, not just from, you know, upcoming bills, but from, you know, 2 stimulus ago. And I'm seeing this in Philadelphia. Programs that were languishing are now rebranded with entirely new interventions and, you know, new websites and flushed with cash. And so, you know, I think this is, I don't, you know, unfortunately, while I think it's this is a very timely time for the book to come out with this idea of we're gonna have all these new programs. You know, the biggest thing is I don't think there's a connection between thinking about programs and intervention and something like drug treatment and the use of their data. You know, in many cities, you know, a lot of this administrative data about people sit in silos and aren't used. So, and of course, these are administrative costs, right? And you know, understandably so, it's like tough to say, well, we're gonna peel off, you know, a couple $100,000 to explore the utility of our administrative data that we haven't ever used, when we can spend that $200,000 on a drug treatment bed, you know, on many drug treatment beds. So I 100% agree with what you're saying. I think that there are now these local governments that are flush with cash that have real problems that they're going to be able to address. And yeah, I mean, the time is now to start experimenting with, you know, I'm speaking with folks in Pittsburgh, and it's the best city for using its administrative data, particularly in health and human services, right? It is just a model for everybody else, but it's also something that took years, decades, not only to build these systems, but to get the kind of community standards built that I'm discussing. So, you know, despite the fact that these governments are awash with cash, you know, I don't see them stepping back and being like, yeah, let's turn into the next Allegheny County.
Right. Our Department of Human Services is enviable. It's probably the best in the country, without a doubt. But like you said, it took decades to build that. And a lot of Hines College alumni are at the helm, including the upcoming director, Aaron Dalton. So I guess what I want to talk about a little bit more is, as you look at, you know, the way we look at smart cities, it's about improving quality of life for all citizens. And so this issue of bias and diversity and equity inclusion, there's so much, and also another hat I wear is with the World Economic Forum, and I'm co-chair of the Trustworthy IoT Coalition. And a lot of this is about the lack of trust, right? And I feel like there is a distrust of technology. There is a tech backlash. What are your thoughts on that? Do you see that in your work, a tech backlash and a lack of trust? Because I sure do.
Yeah, but I mean, I absolutely do. But more so, I see these market signals where you have these gigantic companies who once rushed into smart cities as a marketing narrative, suddenly pulling back. And part of that is they're getting pushback from the communities that they try to go into, who are like, we don't know what this technology is. And these companies are realizing that they tried to rebrand their enterprise scale technology as smart cities. And that was a failing, that label, I think, failed. And again, like Sidewalk Labs is the best example of that. You know, they just failed to get community buy-in. Now, have always had a problem with this term because as someone who has done city planning and technology for years, you know, I just see it as city planning. And I especially, you know, we have a city planning program that is broken out into concentrations, housing or community development or transportation. And the chair of the program spun up a smart cities concentration, which basically took all the MUSA classes, the program that I run. And I was very much like, this is not going to be a good branding exercise for us. Trust me. You know, we want to do something around technology and city planning or data and city planning, fine, but this is not going to work out well. And I think it's been a failed marketing experience, and it is a trust issue. And, you know, you can't just come in with gigantic infrastructure projects, whether they're bulldozers or sensors, and say, this is the way it is now. You need community buy-in.
Absolutely. Yeah, I know. Smart Cities Institute is the last part of my name. And I feel like, you know, like the way we define smart cities is not how Google defined smart cities and Alphabet defined Sidewalk Labs, rather. So yeah, no, I think.
Can I add one thing to that? You know, I think.
Yeah, absolutely.
I think the more successful approach is the smart cities movement has very much been place-based. And I think the more we can talk about the betterment of people and the delivering of services, particularly to those in need it most, that I think that's a better angle for smart cities than remaking place.
And then it's a systems approach, right? And it's also addressing issues like systemic change, systemic bias.
Absolutely.
But I still believe in place-based too. So I think there's something about that, you know, it's the idea that things are very, and that's where the community aspect is so important, that you can't just take a recipe and plop it in one community and expect it to have the same results.
Yeah, I'm a city planner and a geographer, and you can see the importance of place in my work. But I also know as a city planner, there is a history of government coming into place and remaking it in its own vision without engaging the community. And it still happens today. And I'm very weary of placemaking by people who do not have a grassroots foundation in that community.
Right, they're not from that place, right? So I think that's, and sort of like, it's technology and Google we trust, don't worry. That's right. Don't worry your pretty little head over the algorithm.
That's right, exactly right.
I think we're in the final stretch here. I'm going to flash up our slide where it has lots of ways to connect with us. We've got a newsletter, brand new podcast. We're on Twitter, social media, even Instagram. Ken, thank you so much. This was fantastic. Thank you to our audience. This is all recorded, so those of you who watch this later at your leisure, please contact us if you want to get a hold of Ken. And in the chat, you should see the book link right here. And thank you so much, folks, for joining us, and have a great day. Thank you.
Thank you. Be well.
Thanks, Ken. Great job.